ఆ ల్యాప్టాప్ ఇచ్చి ఆడి ఫోన్ నెంబర్ అవ్వట్లేదు డాడీకి రాలేదేమో రోజు.
Sir, good morning, sir. Sir, Paul Ross, sir, good morning.
Good morning, Andy. Good morning.
Sir, welcome, sir. Welcome to the STTP, sir.
Yeah, Andy. Thank you, Andy.
We'll wait till 10 o'clock, then we will start, sir. Okay, sir?
Yeah, sure.
Thank you, sir. Thank you.
Girish garu.
Sir, hello.
Yeah, where I can change the background, that option, whether I can able to change because I am a co-host now.
Yes, sir. You can able to share your screen, sir. Yes, sir. You can.
No, background, my background, whether I can change that.
Background you can't change, sir. We don't have.
I can't change, no?
Yeah, no.
Okay. It is started getting recording.
YouTube we are giving live, sir. Once the session started, we can able to record automatically. This will be recorded on YouTube. We are even recording in Zoom also.
Okay, fine.
Let me see some options.
I'll share my document and I'll check it once.
Okay, sir. Sure, sir. Sir, I think there is one option to change your background. I'll check and let you know, sir.
Yeah, that is, I know, actually it is there in more.
Sir, are you able to change? Should I help you?
Where is that option?
Sir, you go to settings and there will be background and filters.
Settings or security?
So settings, sir.
Settings from where? Settings from which option? Which menu?
I'll tell you, sir. I'll share the screen for you.
వెళ్ళండి నేనేం ఆన్ చేయలేదు.
తర్వాత పొయ్యి మీద పెట్టేసాను, కడిగేసాను. జస్ట్ ఆన్ చేసి ఆపడమే. వాటర్ కూడా కడిగేసాను, పెట్టేసి. ఓకేనా?
గిరీష్ గారు,
హలో సార్.
నేను ఇంకొక వీడియో షేర్ చేస్తున్నాను. అది టెలికాస్ట్ అవుతుంది, మీరు ప్లే అవుతుంది లేదా చూడండి.
ఓకే సార్, షూర్ సార్.
ప్లే అవుతుంది ఇప్పుడు?
నో సార్, ఇట్స్ స్టిల్ షేరింగ్. షేరింగ్ వస్తుంది సార్. నో స్టిల్ ఇట్ ఇస్ షేరింగ్ సార్.
షేర్ అవ్వట్లేదా?
లేదు సార్, లేదు సార్.
ఇప్పుడు
ఇట్ ఈస్ అబౌట్ టు షేర్ సార్. బ్లాక్ స్క్రీన్ వస్తుంది.
నాట్ ఎట్.
Not yet, sir. Sir, video option on చేశారా సార్? వీడియో ఆప్షన్ ఆన్ చేయండి సార్.
నా దాంట్లోనా? బ్యాక్గ్రౌండ్ ఆప్షన్ చెప్తాన్నారు కదా, ఇప్పుడు ఎక్కడ ఉంది అది?
అది నేను మీకు ఒకసారి వాట్సాప్లో షేర్ చేస్తున్నాను సార్, పిక్ ఒకసారి చూడండి సార్. సార్ ఐ గేవ్ అన్ ఆప్షన్ సార్, ఒకసారి వాట్సాప్లో చూడండి. మీ వీడియో ప్లే చేయాలంటే యూ నీడ్ టు క్లిక్ ద 2 టిక్స్. ఒకసారి చూడండి సార్, దాని ఆప్షన్స్ మనం ఇవ్వాలి సార్.
వాట్సాప్ చేశారా?
సార్.
Two ticks or 3 ticks?
There are 2. Share computer sound, optimize the screen share for video clip.
ఏమంటారు? షేర్
ఒక్క నిమిషం సార్. Share computer sound, optimize the screen sharing for video clip. Share option ఉంటుంది సార్.
షేర్ ఆప్షన్ లో
you'll get the 2 box. షేర్ ఆప్షన్ క్లిక్ చేస్తే మనకి 2 ఆప్షన్స్ చూపిస్తాయి.
షేర్ ఆప్షన్ చూపిస్తే అవును ఉంది.
2 ఆప్షన్స్ చూపిస్తాయి.
షేర్ కంప్యూటర్ సౌండ్,
షేర్ కంప్యూటర్ సౌండ్,
ఆప్టిమైజ్ స్క్రీన్ షేరింగ్ ఫర్ వీడియో. సెకండ్ దా
2 options. Now you can share your video and see. Yes sir, మీ మెయిల్ కనిపిస్తుంది సార్.
ఓకే.
Yeah, dear participants, we will start in a couple of minutes.
Yeah.
Sir, first video ni on చేసుకొని పెట్టుకోండి సార్, then you can share, then it will come.
Yeah, correct.
Sir, Venkatapati Raju sir, good morning.
ఇప్పుడు కనిపిస్తుందండి?
యా, మీ స్క్రీన్ కనిపిస్తుంది సార్, మీ డెస్క్టాప్ స్క్రీన్ కనిపిస్తుంది.
ఇప్పుడు రన్ అవుతుందా?
సార్, no, we are still able to see only desktop screen. Now something is coming. Play కొట్టండి సార్.
అవుతుందా?
ఆన్సర్స్ కనిపిస్తుంది సార్. ఆన్సర్స్
కనిపిస్తుందా?
ఆన్సర్స్ కనిపిస్తుంది సార్.
ఓకే, ఇప్పుడు రన్ అవుతుంది కదా ఆన్సర్స్?
ఆన్సర్స్ రన్ అవుతుంది సార్.
This is okay. At final I'll show this. Please help me out at the end, maybe after 1 hour.
అలాగే సార్, షూర్ సార్.
After 1 hour I have presentation. After that I'll show this.
ఓకే సార్. So shall we start now? Just we will have some introduction then.
Shear, good morning.
Sir, good morning, sir. Have then you can slowly start, and then meanwhile the participants can join the remaining ones. Okay, sir.
Yeah, we shall start, Andy.
Okay, sir. Thank you, sir. Sir, Professor Venkatapati Raju sir is there. He is our former HOD and he is a professor in civil department. You can
Yeah,
say
I met the sir. Sir, hi, sir. How are you, sir?
Sir, unmute change, sir. Sir, please unmute.
Are you able to hear my voice?
Yes,
sir.
sir. We are able to hear your voice.
Okay, then how are you? I think we have met once.
Yes, sir. We met once at your campus. Yes,
So
sir.
you are now in Siddhartha College?
Yes, sir. I am Navin Siddhartha, sir.
Okay, then we can start.
Thank you.
Yes, sir. Yes. Thank you, sir.
Okay, sir. Yes, sir. Okay. Right.
Yeah. Good morning to one and all. Shall I start?
Sir, I will no. I will introduce. Then we can start, sir. Thank you.
Okay. Introduce.
Participants, dear colleague faculties and other faculty from other institutes, professors and other professionals, very good morning one and all. Myself, Dr. Palagirish Kumar, working as associate and head of the Department of Civil Engineering at Sri Vishnu Engineering College, Roman, Autonomous, Bhimar, Andhra Pradesh. Department of Civil conduct events for the past few months. We have conducted a string series, 2 series, then conducted a 2 STTP part, and then we conducted a digital and digital competition for students and faculties and others. We conducted AICTE sponsored workshop. 2 phases we have completed, and now we are entered to the phase 3. AICTE sponsored online 1 week training program on soft computing techniques in civil engineering, structural, water resources, geotechnical, remote sensing and transportation. Yeah, very sorry for the inconvenience. Yeah, I welcome you for this AICTE sponsored work online 1 week workshop training program phase 3 on soft computing techniques in civil engineering, structural, water resources, geotechnical, remote sensing and transportation applications. I would like to request my faculty coordinator, Ms. Surya Kumari, to introduce our today's speaker of the session. Over to you, Surya Kumari. Please go ahead.
Hello, everyone. Welcome to today's session. I would like to introduce today's speaker, Dr. Pallaboina Paul Raju, and he's from Vijayawada, and currently he has achieved, he's received his doctorate degree from IIT Madras. under the investigation of structural performance of 3D sandwich walls under general loading, and has completed his master's degrees in the year 2009 at IIT Guwahati for strengthening of beam column joint under using FRP, and he has completed his bachelor's degree at MS Bidwi College of Engineering, Maharashtra for design of bituminous roads, and he has awarded as a he has sanctioned the financial assistance of rupees 1.5 lakh under Science and Engineering Research Board for title International Conference on Earthquake Engineering and Sustainable Construction Technologies. And he's also the chairperson, acted as chairperson at Indian Concrete Institute for Vijayawada Center. He started his career in the year 2009 working as an assistant professor in the Department of Civil Engineering at Lovely Professional University, Punjab. And he's also worked as an associate professor and now associate professor and head of the department in the year 2019 at KL University. And presently is working at VS Siddhartha College as senior assistant professor. He has also visited many countries like Singapore, Jordan for the conference, and also presented his paper in symposium at Malaysia. He was also invited as a guest lecturer, expert talk for technical talk for the many companies and for many institutions as keynote talk and for Ultra Cement Limited as well. Here today's session, we are inviting Dr. Palleboyina Polraju Garu to give his lecture, which will be for us immense pleasure and satisfaction introducing this section. Thank you.
Yes, sir. Please carry on, sir.
Yeah.
Thank you.
Yeah. Thank you, Surya Kumari. And first of all, I would like to thank former head of the department and senior faculty member, Dr. U. Venkatapati Garu, and your youngest HOD, P. Kirish Kumar Garu, and all faculty members and principals, sir, and of course, management of the Sri Vishnu Engineering Women's College. And thanks for this opportunity to inviting me and for the opening session of your phase 3 session on soft computing techniques of civil engineering. However, my presentation I'm going to give today on same topic, but I'm going to cover with the fully structural engineering components. Are you able to see my sharing document, Kirish Garu?
Yes, sir. We are able to see, but there is some blurring. I mean, it's not so clear.
Is it okay now?
It's okay.
Shall I proceed?
Yes,
Yes, sir.
you can.
Proceed, sir. In case if any problem comes, I will eliminate it. Thank you.
Okay, I'm going to give the presentation on soft computing techniques in structural engineering. So that means what I'm going to cover. First, I'm going to cover one multi-story building using both STTP software as well as Etabs software. Later on, I'm moving on to the SAP 2000 software, which is very popular for using advanced analysis like picture analysis, like response spectrum analysis, like time history analysis, like all nonlinear based analysis, you can do it. So that all that software is very popular about that, because the SAP 2000 software is like you can use it directly for the nonlinear analysis, whereas earlier Etabs was not using for the nonlinear analysis. Right now, even Etabs also ready to use for any type of analysis. I'm going to cover like that. Later on, I'm moving on to the few techniques, few works also, like which type of new techniques we can do using these soft computing techniques. And at final, I'm planning to show on ANSYS recorded video for making model and for doing analysis in ANSYS workbench. In that, I'm going to show the shear wall analysis and design. So with that, I'm going to close my presentation today. Yeah, firstly, if you want to do the any multi-story building, as you know that theoretical calculations are most important. Like first we start doing the load calculations, like what are the loads are coming on like slabs, then slabs to beams and beams to columns and columns to foundations. So this is a load transferring mechanism as we know, but directly I'm not showing any that theoretical things and all. I'm directly entering into the software point of view, each and every step-by-step procedure, how we'll make the model and how we'll do the analysis and how we do the design in the this software. So that I'm going to explain here now. So for suppose if you want to create the creating grid from coordinates, like what you have to do, first you have to open the StatPro software from your desktop or some maybe icon. After that, you must select the what is that space or plane or whatever. That depends on your requirement. But generally, when you do the building multi-story building, that is 3D only. That means XYZ coordinates are there. So for that, there is another direct option also, run structure wizard in the StatPro. So run structure wizard, actually ready-made some models are available. So that models also we are not going to select. So we want to customize our model by making our own model, and we wanted to customize and we wanted to extend the number of nodal points, even length of the beams and everything, like add beam options. So that how we can do by using the coordinate system. So you can see the right hand side here. There are tutorial notes, and these are there. From here, what we have done, 0 0 0. That means XYZ we have given as 0 0, and after that we are going to make only one portal frame. So portal frame, yeah, I can show like this. So portal frame we have to make like this. So that can be seen here in the next step. Yeah, see vertically there is another node. For that, what has been given at y-axis, it has given 3 and 3000. That means 3 meter height. So then after that, what it is given from the menu geometry. From the geometry, it can be given that. From the geometry, it can be given that add beam from point to point. So after that, so you can draw the one point to point, whatever the nodal points we have created. Then after creating the nodal point directly by using again the geometry option, after selecting this created add beam with in between two nodal points, you have to select that and go to the geometry again and take the translation repeat option. So translation repeat basically happens like this. When you open this, it will give the global directions like X, Y, Z directions. So I wanted to copy along the Z direction, say, and what are the intervals I want, that to how many steps I want, how many bays I want. So that is 4.2 meter bay width. And again, I wanted to make around some 5 bays. So for that, how I have created, you can see here. So this is created. Then after that, again select, and wherever I want, like now X direction, I want how many. So it depends on your building plan actually. So after creating like this, everything, you can create the all connected beams on the top floor, because at the bottom that is like nothing but a foundations. So foundations generally fixed support will give. In the software also will give same scenario manner. So after creating that, it's like a typical, you can see it is a typical customized plan. Like one side is there are number of spans are there, whereas in between it is reduced, because it is actually maybe a lift area, lift portion. Even there is a open to sky area. These all are there. So it's a typical plan. Of course, when it comes to the model, you can understand that. Then using translation command, replicate frames for higher stories. Like now again, using translation repeat from the geometry, it can be replicated from whatever we want from the vertical direction now. So this is ready now. So you can see the vertical direction. So likewise, modeling of the frames of building complete. You can select you can put the front view of your total model. Then go to the select option. In that node cursor, you can select, and you can select the all bottom nodal points at the bottommost nodal points. Then at a time, it will be selected. It is looking like only one side selected, but it will be selected in overall our building under the all nodal points. Then select that support sections, that the support option, create new support condition from the menu bar here. You can see here support conditions here. So from the support condition, you can create the fixed support. After giving fixed support, you can apply the fixed support. For fixed support, generally, you know that three translations and 3 rotations would be there. All are, you have to restrict. That means you have to hold that. So fx, fy, and fz, mx, and my, and mz, you have to hold it. then you have to click on that. Actually, you have to check that. So once you check on that, and if you add that option, it will be added and it will be assigned to the respected selected nodal points at the bottom. Now your total building is at the bottom fixed actually, because it indicates the simulation of the fixed support of the your building, like foundations generally, because all buildings are nothing but a cantilever problems. Is it correct? So cantilever problems means one side is fixed and another side is free. So if you talk about your building topmost portion, that means terrace portion, it's a free actually. So your building is typically nothing but a cantilever problem actually. So fixity assigned. So now 3D view after support assignment, you can see everywhere it has been assigned. Then after that, you can add the plate command to create walls actually. That can be done from geometry, from add plates. You can use the quadrat, because quadrat means 4 points you can get it. So wherever you want, you can select that 4 points, depends on your nodal points, wherever you want the wall or slab. So slab is nothing but a diaphragm actually. So modeling of shear wall is complete now, because see, by using this option, it has been created shear wall here. What is shear wall? Shear wall is nothing but like a lift wall here. So majority cases, if you see lift walls generally like a solid concrete walls. So it will act as a shear wall as well as for your lift purpose also it will survive. So after creating that, you can see the top view of the your shear wall portion. Now, after shear wall completes here, the next point is you can create the slabs at the different floors. Now I am creating at this is actually according to my understanding. I will not say it is a cellar or something or ground floor. It is basically stilt. Wherever you are parking in any apartment, that is basically stilt floor. Just above the stilt floor only is the ground floor actually. So above the ground floor is a G+1, G+2, G+3, G+ floor like that. So this is very important, especially when you talk about the jurisdictions of the Vijayawada building bylaws, Guntur building bylaws, Hyderabad building bylaws. Based on that only, they will give the approvals of the number of heights of the multi-story buildings. So even depends on your road width of in front of your site. For suppose you have very heavy site, but your road width is only 12 feet. So they will not give that much height of the building to construct. And it will vary again from Gram Panchayati to corporation. If you talk about the Vijayawada corporation, the rules and regulations, all setbacks will be totally different than compared to the in Gram Panchayati. Gram Panchayati, there is no much critical like permissions required. You can go with some flexibility. Even setbacks point of view, there are some guidelines even they're providing. Like if you talk about the VMC, Vijayawada Municipal Corporation, now it is converted into CRDA, Capital Regional Development Authority, like Visakhapatnam Municipal Corporation, like that. So this is the idea. We know already how we get the permission from the for house construction, how we draw the building plans to get the permissions, and how we have to leave the setbacks. Those are all very important. But this is, I would say, stilt floor, and for this is nothing but stilt slab actually, stilt roof. So this is stilt roof slab I have created. Once wherever I have created, I no need to go to every floor. Wherever I have created, I can copy from one floor to all remaining floors actually. The same command, translation repeat. The work will be very faster, I'm saying, because why we are using StatPro software instead of manual calculations means to reduce the time as well as to increase the accuracy actually. Finally, we will cross check with manual calculations, but we will do the in the softwares to reducing the time, because when you talk about the G+1, okay, G+2 okay, up to G+2 also okay. But what about the G+5, G+10, G+20, even G+100? So that time you must welcome the very good accurate software. So I would say StatPro somewhat reliable software, but in the software you can't make the, after doing the analysis and design, you can't create the drawings actually. Whereas some other softwares are very good softwares, we can create the drawings after completion of the analysis and design. But StatPro software, I would say, still one of the leading company in our India, L&T, still they are using StatPro software. What they do all analysis in the software, and they will take the all analysis values and design. Again, they will approach the Excel sheets for doing the one continuous beam, even slab, even two-way slab, one-way slab, even for columns. In the columns again, axial loaded columns, biaxial loaded column, even pure columns, even footings point of view, also combined footings, isolated footings. For everything, they have one prescribed Excel sheets. So in that Excel sheets, if you go and place this all bending moment and shear force values, magnitude values, which you adapted from the software for checking purpose, scratch checking purpose before releasing the any execution drawing. So they will cross check with the Excel sheet. In the Excel sheet, when it's once it is satisfied, it crosses the, it's passed the design as per your IS456 classes. Then you are in under the limitations and under your control. So after that, it will transfer to the drafting section. In the drafting section, again, everything will be ready. They will only modify, sometimes they may use with scale, sometimes they may use without scale, not to scale. So generally, if they are not using not to scale, only by changing the depth of the beams, for suppose depends on your building analysis and design, and what are the loads are coming on your building, and your building is located in again different places. If your building is located in Guwahati, you must consider earthquake loads. If it is building is located in Hyderabad, okay, it is zone 2 only, not that much worry about the earthquake loads. But when you talk about the Vijayawada also, you must consider the moderately earthquake loads, whereas your building is located in the Delhi area, again you have to calculate, you have to consider the earthquake loads, because that is zone 4. And check geometry for multiple structures, whatever the model, everything is created. We have to check the multiple structures, like any duplicate nodal points are there, or any duplicate members we have created, because it is very so clumsy. Even simply, I can say this is a little bit work only. When you talk about the G+100, that time heavy work will come, and heavy number of nodal points and number of beams will come. There may be a chance of overwriting of the nodal points as well as members. So that you have to check by going to the from menu bar tools, check multiple structures. Then after that, it will be checking again check duplicate nodal points also can be checking like this. So the enter tolerance means, so you are not at all allowing any tolerance, because if it any closely one nodal point is created without your idea, without your notice. So that tolerance you have to give, so that everything will be adjusted. So once that is over, the next portion is entering into the geometrical properties, because if you want to do the analysis for the created one model, this is only now skeleton. You have to give the beam depth as well as width also. Again, column both cross section you have to give. So even slab thickness you have to give. Even height of the column and length of the beam already given in the model itself, normal model itself, skeleton model itself. Now you are giving the geometrical properties of the both beam and column actually, and even slab. So it can be given, and once whatever you have given, these all things you can see the right hand side rectangular 0.45 means 450, and 0.3 means that is 300. Again 0.23. Why is 0.23? It is actually for the beam. Why it is 0.23 means, generally beams, all beams should flush with our two thickness brick wall actually, two brick wall thickness. What is two brick wall thickness actually? 230 9-inch wall. 9-inch wall is nothing but 230 mm. So it should flush with your beams. So that is why the width of the beam, and another thing is that width of the beam will not influence anything actually. Depth of the beam only will influence the bending moment, whatever it is coming. For suppose one column to column distance is say more than 5 meters. As per my experience, I'm telling you, you must introduce another column in between. Otherwise, you must go with the beam depth as a more than 600 or 750. If it is beyond going 750 mm thick depth beam, and again you have to introduce the side face reinforcement as per code. And again, it may lead to deep beam actually. And deep beam actually predominantly fails in shear. It is not strong in shear. So again, that problem will come into picture. Again, you have to focus on both horizontal and vertical reinforcement very carefully. Again, deep beam is another old, I can tell you, because it's a worst subject, deep beams. A lot of research is happening at the very good primary institutions on the deep beams. So that's all about the when you increase the one column to another column distance very higher, say like community halls are there, like otherwise any prayer rooms are there, like cinema theaters are there, and you're going for the slab roof only. So that time you don't want any intermediate column, because intermediate column will create a lot of disturbance to the viewers. So that's why you wanted to put the columns at the both ends only, but your width almost around some 10 meters or 15 meters are there. So that time, what is the best solution? Deep beams only. Otherwise, waffle walls, waffle slab. Waffle slab means small box kind of things you might have seen. That means a number of beams combinations will be there without intermediate columns. At the end also columns will be there, but it is so costly actually, because number of beams you are going to introducing, and it will look like a one box kind of roof. You can see that is nothing but a waffle slab. So that is one idea I'm giving. Anyhow, beams parallel to X means everything will be selected along the horizontal direction. And again, beams parallel to Z also can be selected, and another direction can be selected. You can see in the coordinate system. What I'm explaining here, please look after here coordinate system, X and Z, and Y is always vertical. Okay. So after that, once you select it, it has selected and it has assigned now the beam dimensions. Now again, select the inverse beam selection means sometimes if you want any, like in the rooms, in the inside of the room, if any beam is coming, that beam you wanted to shift it into wall, in the above the wall. You don't want to keep it in the in between the center of the room. So that also comes under the inverse of the beam selection. So that can be also done. Then after that, select all plates and assign the plate property, that is thickness. After that, when it comes to the lift area, there are simply supported beams also. Sir, simply supported beams, directly we will keep the roller and the hinges? No. Roller and the hinges we will not keep. It will look like a rigid beam only, but we will design that beam it is as a simply supported beam. How we have to design a simply supported beam? Basically, for the fixed beam, your minimum diagram formula is with UDL WL square by 12 actually. For simply supported, WL square by 8. So in WL square by 8 means denominator is only 8 for the simply supported, whereas for fixed support denominator is 12. That means it indicates you are keeping more reinforcement in the simply supported beam only. So likewise, you have to create the you have to design the simply supported beam wherever it is required, especially secondary beams. Secondary beams means the beams are resting on another beam. So which beam is resting on two columns, that means supports, that is main beam. So main beam is directly, it's looking like a rigid beam only, that is nothing but a fixed beam only, whereas the secondary beam which will rest on the another primary beam, that is actually how to convert into simply supported beam. What you will do the process in the software, you will release the moment actually. You know contra fracture, point of contra flexure. If you talk about the simply supported bend moment diagram, and if you talk about the bend moment diagram for the fixed beam, that you can understand it. Negative bending moment you can observe at the fixed support because of the fixity at the both ends. So negative bending moment is coming means you have to provide the additional reinforcement at the top. Whereas in the positive reinforcement means you will keep at the bottom. So that is the detailing, even reinforcement detailing. So that practically we follow. And in the software, you have to release the movement there. Then automatically that beam will be designed as a simply supported beam. So this can be done like this by selecting this option. You can select this and you can release the wherever you want the movements. So once you release the movements, you can see here, this beam is simply supported beam, and this beam is one side is simply supported. That means it is not fixed here. And again, this beam is also one side is fixed. On one side is fixed, and another side is again free. But this beam is looking like a simply supported beam, and this beam again simply supported beam. And here also this is simply supported beam, because depends on your see this beam. If you take this beam is resting on two supports, correct? Two supports, nothing but two columns. Whereas this beam is not resting on any column, so it is resting on beam. So this is secondary beam actually. So this is all about the releasing the options and how to convert the beams from fixed support to simply supported. Next, moving on to the another thing, load cases like load assignments. Now dead load, live load, these are the service loads. Apart from that, wind load and earthquake loads are occasional loads, like depends on your requirement and depends on the locality of the building construction. You have to adapt the both wind loads and earthquake loads. When you talk about the wind loads, actually up to 10 meters height of the building, you need to consider the any wind load actually. Beyond 10 meters, if it is going beyond 10 meters means how many floors around? So each floor 3 meters. That means after 3 floors only you have to consider the your wind load effect. But once your building is more than 10 meters height, you must consider the wind load on your entire of the building, entire height of the building. It's not that up to 10 meters no need to consider. So above that only let me add the wind load means that again that will give another problem. So the condition as per code of IS 875 part 3 is up to 10 meters height, any structure is there, you don't need to consider anything, wind load effect on that. If your building is going beyond 10 meters height, you must consider the wind loading on that, on the entire height of the building of two methods. One is nodal method, otherwise diaphragm method. Nodal method means at each and every beam column connection, it's nothing but a nodal point. At beam column connection, by converting this all wind pressure on wherever it is acting on the columns, converting into at a nodal point as a 1 point load actually, because pressure is always kilonewton per meter square and uniformly distributed is kilonewton per meter, whereas load, point load is nothing but a kilonewtons actually. So like that you have to do. Another thing is on the diaphragms. Diaphragms means slabs. So slabs are actually monolithic with the beams. So that means entire wherever beams are coming, you're directly giving the like a one pressure kind of thing. That is another method. But best way of applying the wind load is nodal method is best way of applying. Otherwise, applying entire on your building on the four sides like a pressure, that is also very best way of method of earthquake wind load application. Whereas earthquake loads actually again depends on your zone 2, zone 3, zone 4. You have to first do the model analysis, then again response spectrum analysis. After doing the response spectrum analysis, you may adapt again maybe a time history analysis, again response spectrum analysis. If you do from there values, you will get it like PGA values, pre-ground acceleration values. That values you can apply in the software. So that building will take the even earthquake loads also depends on what are the loads coming practically depends on the location of the building. Then creating load cases here, dead load and live load. It's very simple thing. Now I'm doing. I just explained about the wind load and earthquake loads extra, but we are doing here only for the service loads, dead load and live load. Under the dead load, you can first adapt the self weight. Actually, self weight is nothing but a 25 BD. 25 is the density of the concrete, and B is the breadth of the member, and D is the depth of the member. And one unit we will not consider, that is length of the members, because automatically the length is inbuilt of your calculations. That is why we are keeping that is into per meter length. This factor is per meter length. Why minus? Downward, because the self weight is always will act as a downward due to gravitational effect. It's not going to the up. If you are not adding this symbol minus, and load will go up, and your calculations and all results will be vary, and it will be not accurate. Actually, it is inaccurate. And again, after that, you can add the after self weighting, you can apply on that. Then you can add the live load. Under the live load category, you can add, it is nothing but a corridor actually, lobby. In the lobby is something load you have to apply, and whereas another load wherever you are staying, like pure residential area, live load will be different. Because in the lobby you will not keep any cot, that means double cot. You will not keep any furniture. You will not keep any sofa seat. Maximum you will walk. Only human beings will walk in the lobby. So lobby load will be different live load. Based on that only you have to design the slabs. Why unnecessarily you have to put the extra loads on all labs similarly? So that basically do like a mass way of doing, like construction of the one G+5 Masonry, Mason also he will construct, engineer also he will construct. What is the basic difference between him and us? We have to look after the economical construction and economical design we have to give. Whereas he will do everything like a thumb rule. He will not even take for checking the level of the wall, plastering and all, spirit level he can't take. He will take one tube by filling the water. You will hold one side and another end you will go and hold another side. Both levels are same means for him like leveled only. But that is not accurate. That is not accurate. Even what basis you will design the beam actually. Even if you do typical calculations also, whatever he is providing practically without doing any design, the same thing will come. But according to our engineering point of view, we must think about the economy, like where bending moment is coming maximum, where bending moment is coming lesser, which type of bending moment. It's a negative bending moment or shear positive bending moment. These all factors we will see. Whereas he won't see. What he will do, I'm telling you thumb rule how we will follow. For 1 feet of the length of the beam, he will provide the 1 inch depth of the beam. That means 1 inch depth means 2.54 centimeters. 1 feet length of the beam means so 1 feet means 30 centimeters, 12 inches. Okay. So like that, you will follow the thumb rule. For suppose you have a 5 feet beam, how many inches you will provide depth of the beam? 5 inches. 5 inches is nothing but a 5 into 2.54 centimeters, and convert into 10 you put. You will get it in the everything depth is in the mm actually. So this is the thumb rule he will follow. He will not do any paperwork on his own design. But they are constructing even G+2, G+3 like that. But the difference is that. So the difference why I am explaining from the deviating from this discussion, when you clearly see from this photograph, this is looking like a lobby, whereas these are like like living areas, actual living areas. So like this you can see it has been observed, and now load is also applying like this, and after that wind load definitions also applying whatever I explained you. The wind load calculations, everything is available ready-madely. When you go and select the new add load, then it will give the wind effect, but depends on your severity and even the calculations as per IS 875 code book you have to do, and you have to apply the loads on this wind loads. That is manually you must study with that, and in the software point of view you have to apply like this. So after applying this, you can see, and this is all about next step is seismic loads, actually earthquake loads. So earthquake loads also again zone 3 or zone 2, zone 4 or even zone 5, otherwise zone 2. So like that you have to select it, depends your building location, and you have to apply the all factors by calculating. You can see this. Now the next important thing is dead load and live load combinations. So dead load, live load combinations you must select, that is into 1.5. After that, you must move on to the design, actually the concrete design. For that concrete design, you have to select the IS 456 code book. There are number of code books are available. So you have to select the code book IS 456. After that, you can give the perform, of course, perform IS 456 code book. In that, these and all actually select parameters. After selecting parameters, you can define the parameters. What are these parameters? Clear cover, even depth of the beam, even FI main, FI secondary means yield strength, and yield strength secondary steel and main steel, like that. I'm giving compressive strength of even concrete. Then this is yield strength of the main. Likewise, whatever the parameter selected, everything can be given. Now the analysis part also can be done like this. Then after analysis, the design concrete beam, if you select one beam here, see selected, and when you click on this, the design has to show like this. So this design may be final. It may not be granted actually directly. We can't take it as a granted, but analysis point of view, the shear force and bending moment magnitudes are most accurate in the STTP software. Design again, you can do it separately. So likewise, the output also can be taken. Then I'm moving on to the another software, that is Etabs. That is different feel and the different interface will give by STTP software, and that is developed by Bentley people actually. Whereas Etabs developed by CSI people from US. So this is it's a sister software from the SAP 2000. SAP means Structural Analysis Programming Software. But whatever software you take, like there are plenty of softwares for doing analysis and design in the structural engineering point of view, like SAFE, STRAP, StatPro, Struts, Etabs, SAP 2000. There are plenty softwares are there, like NASA, Diana, TNO Diana. Of course, those are modeling softwares like Abacus, like ANSYS and all. if you take any like analysis softwares, basically, what is the background method for doing this all analysis, like shear force and bending moment, how it is running for the multi-story buildings, even one small beam also, how it is running, which method it is taking, whether it is taking moment distribution method or slow deflection method or Canis method, which method it is taking. So these are these softwares and all running with the advanced technique method. Those are like flexibility matrix method and stiffness matrix methods are there. So in that again, I would say this software is running behind the backup of the analysis for the softwares are stiffness matrix method, because stiffness matrix method is displacement based method. So displacement based method is most accurate one than anyone. So based on stiffness matrix method, the program has been everything like written, and this software is interfaced like that. That is why the software, we don't know this actually. What we are doing, the interface is very user friendly. You are going into the menu and all, and even in the YouTubes, there are plenty of videos are available how to analyze the one building and all. But when you talk about the one typical project and if typical one idea and on project, that you can't get from the YouTube actually. Further, this kind of sessions only will help you. Okay. Yeah. I'm moving on to the Etabs software, how it is runs analysis and design. I may be very faster now after, because the idea you got it, how to do the analysis and design by using the first primary software, that is STTP. So Etabs software, like interface is totally different. Like when you open this one, you will be getting the interface, introduction interface like this, cover page like this. After that, it will move on to the model initialization. You can select the code book of the both concrete and steel, and you can take the units also. Then later on, you can select the model, how many grids you want and how many grids base you want along the X and Y and Z directions. And you can, if you want, you can customize this actually from point to point. That means you don't have any similar spans of columns like 4 meters and 5 meters. You have different type, 3.5, 3.75 meters lengths are there. That time you can customize like this by clicking onto this option, customize grid spacing option, edit grid data actually. So after that, you can select grid only and say OK, and it will move on to the actual working area. And after that, as usual, metal properties, you can select it. M30, it has been selected here. And that is inside also, you can change the all parameters like Young's modulus, even Poisson's ratio, coefficient of thermal expansion for the concrete and shear modulus. Concrete for Young's modulus, how you to calculate 5000 root FCK. This is for RCC actually. For PSC, that means pre-stressed concrete, 5700 root FCK. So this is as per code book. But as you know that IS 456 code book is getting revising now. Very soon, I think maybe 2021 January you can expect. It will be in the implementation actually, because hereafter there is no more pre-stressed code book. Pre-stressed code book also they are merging into IS 456 code book only. Okay, it is going to be very heavy volume actually, that IS 456 code book. It is doing by Dr. C.V.R. Murthy from IIT Madras along with Rupen Goswami and with some other IIT professors and faculty members associating with that in that revision actually. Then defining sectional property, that means the column size and beam size can be given like this. There are ready-made section properties are there, like rectangle, square, circle, like another type of sections also. It can be selected like rectangle, and you can edit the all input data, inside data. And the frame section property reinforcement also can be given like column reinforcement details. Then beam reinforcement details can be given like this. But what is the great advantage in the STATPro software actually? At a time, you can do the all floors at a time only. It's not like STATPro. STATPro, you created the one floor and copy to another floors. But when you talk about the Etabs actually, if you select the all stories, whatever work you do at the bottom, it will be automatically applied to the top floor also. That is the great advantage. At a time, at a stretch, the work will be completed in the Etabs actually. Then draw, click, beam and columns option. You can draw like this. At a time, one box, selecting box, you can do it, and you can apply the columns for the whole your building plan in the Etabs software. Work will be very, very faster than STATPro actually. So it can be seen like this. Then selecting joint resistant command, that means support conditions, similar to the earlier work. Then again, keep selecting command for the drawing beams and selecting beam cross sections. Whatever the beam cross sections you have given, you can apply that. Now you are ready-made ready 3D view of the your modeling, building modeling, frame modeling. Then once that is ready, now you can go for the slab sections. Slab sections also you can apply like this, and like that is again similar to the shear wall at the what I would say like lift area. Then move on to the slabs creation of the horizontal slabs each and every floor. Like this, you can get it. Then releasing options for the secondary beams, the same scenario what you have done in the STTP software, and loading patterns now. And now we are adding into the loading, defining the loadings, and now we are enabling visibility of slabs for easy selection. That means, like when you are selecting, it should not select the overriding of the another nodal point or something. Whatever you want, if you want to select, you can do this option. And selecting all slabs on individual floors. Yeah. Now modifying the wind loads actually. The wind load, all calculations like, windward coefficient, leeward coefficient, these all calculations are available from the IS 875 code book. So there you can realize what is basic wind speed of Vijayawada. So that is there in the appendix actually, 50 meters per second. That is the basic wind speed of Vijayawada. And even 44 meters per second for Delhi like that. And Visakhapatnam also similar to the 50 meters per second like that. So the wind calculations can be applied like this. Then earthquake loads. So earthquake loads again, that depends on your zone factor, jet value, and your response spectrum. It depends on your response spectrum. You have to give all these values. And once that is over, load combinations you have to work on it. Once load combinations are over, then you have to apply whatever the loads you have taken, you have to apply the loads on that now. Once loads are applied, so everything will be ready like this. Now you are setting the analysis, run analysis. So run analysis, once it is over, your output will be shown that the deformation diagrams of the whole building. Then once deformation diagram of the whole building is completed, then you can see all shear effects and bending moment and stress concentrations, everything like this in the different colors. Actually, it shows the level of it is actually like a finite element analysis kind of interface actually. So that facility is also there in the latest version of Etabs actually. So like this, you can see the all forces. So once that is over, then moving on to the another portion, that is concrete design. So concrete design also, as per availability of the options, you can apply the same scenario, but the beams and columns, what basis we will do the designs means, the PM interaction curves, PMM curves, MU by FCK BD square at the vertical side, and whereas at the bottom side you have a percentage of the steel, and PU by FCK BD, that is for axial point of view. So both column and beam, PMM3, PMM2. So that is also one basic thing you must understand, because it will help you when you move to the P delta analysis for the high-raised buildings. That point will be very helpful. It's like a advanced idea about the analysis and design of any building actually. Then once that is over, this report can be generated like this. Yeah. So which is actually repeated thing. That is why I'm skipping. Don't mind otherwise. Yeah, if anything is not satisfying, that means if it is not passing, like depth of the beam and column, size of the column, if it is not satisfying, automatically it show that it is not satisfying. Then you can revise that column and beam. So again, do the start designing. It will do the redesign, and finally it will give the your both analysis and design in the even Etabs order. So now I'm moving on to the SAP 2000. Using the SAP 2000, I'm going to show the pusher analysis. So we will discuss on the what is meant by pusher analysis. For that, first of all, you must do the model analysis for the given building. Like maybe you have one G plus building, but with a different planning. Plan is there. It's not like a one similar plan like two room building or 4 room building. It's like customized building is there. Like live structure is there, So you can take that, and for that you can do the pusher analysis. What is meant by pusher analysis? I'll give you one very good idea on pusher analysis. Pusher analysis is basically a non-linear static analysis. First point. After that, in pusher analysis, what we do actually, for existing buildings you can do pusher analysis, and for the proposed building also you can do the pusher analysis. Pusher analysis, why we do? To know the difficulties and problems, structural difficulties and structural problems in the one system. System is, it's maybe a structure, it's maybe a bridge, it may be a one building or anything. For anything you can do the pusher analysis. But better for the buildings, actually the pusher analysis is shown very good agreement, very good results actually. So in that, what the way of doing pusher analysis, how we do? Through hinges, plastic hinges we will do actually. Plastic hinges means, you know that. So at the nearer column and beam, wherever it is connecting, like beam column joints, we will release the, we will apply the plastic hinges, and through plastic hinges we will give the some horizontal loads. So through horizontal loads, almost building, we will shake the building. So by shaking the building, in building at the beam column joints, in the even at the like shear center places, and where the critical places are there, the all problems will come out actually. These problems will come out in the shape of two curves in the pusher analysis. One is pusher curve, another one is demand curve. In pusher curve, it will show that now the building, where is the position actually, building is in the, under the which condition. In the demand curve, it will suggest you that whether you have to go for the rehabilitation or repair or retrofitting. 3 R's. Repair means is very local thing, and it's not you should not worry about that. Rehabilitation means something damaged and you are getting back into the original position. But retrofitting means whatever the strength is there, you are upgrading the strength actually. Nothing happened to the structure, you are only upgrading the strength because for your future needs. So that's that will give by your demand curve. So we will see that step by step procedure in model analysis. So this is SAP 2000 interface. When you open that, it will be opened the window like this. This option actually new window you can, but in the both StatPro and Etabs, you must select first actually. Maybe I might have missed that step to explain. You must select the units first. That those are available at the right and right down corner. But this is version to version, it has changed actually. Now again in the latest versions, it is showing in the starting steps itself. But in the older versions actually, after opening into the interface, this was showing at the bottoms like this, and by the drop down button you can select this. Depends on your 3 systems are there. One is CGS, FPS and MKS system. So based on that, we are using CGS system actually, basically centimeter and grams and seconds. So as per our SI, the standard international standard units, you can select it and go with the same thing, like kilometers and meters and like like grams kind of thing. Yeah, moving on to the next step, select the new model here. You can see this new model. Then choose a 3D frame template. So 3D frame template can be selected here from 3D frame. Then after clicking on that, similar to the Etabs, you can select the number of bays and number of floors, how many you want. Then you can customize this if you want, editing the grid data. And once everything is ready, your model, full-fledged model, made ready model will be shown in the window like this. So once that is ready, go to the define and give the material properties. And concrete you can select. And in the concrete, again, you give the internal parameters like small days and everything, etc., etc. Then frame sections also can be given, like what is the size of the member, like that. Then add rectangular you can give, and depth and width of the beam, beam and columns also added. C1 and C2, C3 like that. Then area sections, that is for slabs actually. So shell thickness can be given, that is generally 115 mm thickness, otherwise 150 mm thickness, 130 mm thickness like that. But here it has been given 135 mm membrane or even pending, both are same. Then going to plan view. Now set 2D view actually. After setting 2D view, that means top view. Then you can give the for the bottom floor. But in the SAP 2000 software, if you want to go to the bottom floor, there are options like here. You can shift into the any floor by you can see the arrows points here in this menu bar, in this toolbar. Yeah, these arrow points will take you to the different level of the floor. This is a little bit difference between Etabs and SAP 2000, but majority commands and the working style and working interface will be almost same. After creating this, you can see the slabs. Then you can, after creating the slabs, you can copy from bottom to top wherever you want the replication. So once replication over, assigning frames, frame sections. So frame sections over means you can go with the running the analysis directly. So dead load and model analysis can be do very simple analysis. Like model analysis means what? With only self weights it will run. You are not applied any type of load on this. Only it will run with only self weight. That means whatever the depth of the beam and the depth of the size of the column, the self weight only will run. That is nothing but a model analysis. So displaying in deformed shapes, and you can see that in the different modes actually. In the different modes you can see the deformation diagrams, and now it is bending moment due to dead load actually. So that is dead load nothing but like self weight. Now once that is over, that part you have to do compulsory you have to do for the any structure actually. After that you are moving on to the response spectrum analysis. Why response spectrum analysis required means because basically you wanted to apply the horizontal loads in the form of earthquake loads. You must do that process also first, then only you have to go to the pusher analysis again. Response spectrum analysis, how we do, you can see the step-by-step result. Go to the define load cases, and when you can add the from drop down button, there is nothing but response analysis, like a type of category, nothing but a quake. After applying that, you can apply the one parameter of applying on this slabs actually. Yeah, it can be, you can see from here displaying the assigned live loads. So once that is over, go to the functions from the define. There is a response spectrum. In the response spectrum file, if you select, it will generate automatically the response spectrum values, which are already interpreted in the software, depends on your zone factor. So based on the zone factor only, because you are doing your building analysis and design for the zone 2, based on that only these values will come. So these values you have to take, and you have to generate the response spectrum function definition here. And if you want to edit little bit, you can edit, but these are the values are most important from that file actually. So after that, again go to the define and combinations, and add the dead load and the live load combinations. And now analysis cases, go to the response spectrum analysis under the earthquake load also, you can add that. Now you can set that analysis case data, and you can add that response spectrum analysis here. Now you can set the analysis to run. Now along with the dead load and live load, everything now model, even earthquake load response spectrum analysis also will run simultaneously. So once that is over, you can see the all bending moment and shear force diagrams for the different load conditions. Now this is over. The whatever the response spectrum values can be taken from these show tables. Go to the display and show tables, and from there you can select the response spectrum values, and you select everything and take these values and export all tables to the Excel actually. So in the Excel it will select, you take all this U3 and R1, R2, because these are the in the earthquake, if you see, we will calculate the base shear. If anybody knows idea about that, if faculty members or anyone is there, they may understand. Even master's degree level students and PhD holders, they may understand what I'm speaking about, the lateral loads in the form of base shear calculations. So that base shear calculations can be taken directly here, and these are the values. Those are depends on your height of the building, and these values shown here in the mass distribution along the floor heights. And now pusher analysis using SAP 2000. In the pusher analysis, go to the edit grid data by clicking on the window right click button. So once that is over, comes, now if you want anything addition, especially this pusher analysis, how you will do at the center mass center of the building, if you will go and you will remove some portion there, and you will apply some horizontal forces, and basically you will shake the building actually. So that's where we are doing it. You can see the removal portion is this one. Now deleting slabs and inserting joints at intersection of beams and grid lines. selecting the joints for assigning constraints. Yeah, you can see this. Yeah, step by step we can see this. Diaphragms means those are assigning joint constraints there, and selecting all the joints, that changing labels of the when joints at all levels, and breaking beams at intersections of joints and members, assigning storage mass, okay, at the center of mass, actually at center of mass, and assigned floats masses at the center of mass, different levels. You can see now. Are you able to see what the procedure what I have explained to you? The values which are shown in the tabular form has been given here at the center now along this direction. And again now lateral forces along floor heights also shown here. And now along with the earthquake load, you are adding as a push, that is also under the category of quake only, correct? So now defining load cases for push load analysis, assigning lateral loads at center of mass. Now you can see that. Okay. So defining hinge properties now, frame sections, you can do that, and the hinge portions, because as I told you, push load analysis through hinges only you have to do at the beam column joints. Now you applied the load, the push load you applied at the center of mass, and you are planning to shake the building, but to resist that you have to give the plastic hinges at the beam column portions. In the beam PMM2 you will give, and in the column PMM3 you will give. See, these are the defining of the hinges. So once you define the hinges will look like this. Now the next step is assigning hinges for beams and columns, and defining nonlinear cases also. Like again, load cases we are setting up. Earlier it was a linear case, linear, now nonlinear static case. So once you set that, then nonlinear parameters also it will show. Then you have to cross check this all nonlinear parameters. Almost by default you can keep everything. Then now you are defining the load cases as usual, from dead load, live load, even model load, and the response spectrum and push load analysis load. Now you are analyzing the total analysis, and hinge results you can see, whatever the hinge results you can see, whatever we assign, it is showing like this, correct? Yeah, you can see from this photograph the hinges at the beam column connections, and nearer to beam column connections you can see these are the like most critical places to take care of. There are some guidelines are there, like immediate occupancy, life safety, like that in the pushover point of view. So based on that, you will decide the present position of the pushover, present position of the system. Then this yellow curve is actually a demand curve. Actually, it's a demand curve where it is falling. Based on that, you will decide whether you have to go for the retrofitting or rehabilitation or something else. Yeah, this is actually hinge results it is showing. Now, by using pushover analysis for the different ideas, applications in the structural systems, like one very great idea actually, very soon, my dear participants, very soon, no more limit state method also. Working stress method, we are not experiencing it. We are not in practice now. Limit state method we are using. In the limit state method, what is the main criteria? The parallel safety factors are there. Two are there, like one is limit state of collapse, and another one is limit state of serviceability. Limit state of collapse, it will come flexure, shear, even this thing, compression and everything. But when you talk about the serviceability, deflection, cracking, fire, everything will comes under the servicing. What is the great advantage with the limit state method? Why it was very popular from the 2000 when our code has been revised in the year of 2000. See, 20 years it has taken to revise again our IS-456 code book actually. So why a limit state method is so popular? Because of the lot of safety you are doing in the two sides actually. One is strength wise you are doing, another one is load side also. That means whatever the load is coming on your building, you are assuming it is as a higher load, and the strength what it is there in your existing building or your proposed building will be less. That means the 0.15 you are multiplying for the loads, and your 1.5 for the concrete, 1.15 for the steel, you are dividing it. When you are calculating the 0.87 FI, how it has come, and again 0.6 FCK B into XU, how it has come, that everything because of parallel safety factors. So there, the another innovation and another advancement has come, that is performance based design. This is a counterpart to the limit state method. The limit state method, which is very soon it is going to vanish. Very soon, already research is going on this performance based design in the, especially in very good institutions like IITs and even foreign countries like very good institutions like Berkeley, like Cambridge University, NSU. In Australia also, few universities are doing research on this. What is basically performance based design means you will fix the targets actually, and hereafter our criteria is not going to be a P ground acceleration. Our criteria is going to be PCD actually, P ground element. Linear now, then slowly they will move on to the non-linear. Linear and non-linear. When you come to the up to elastic point, that is linear actually. After the breaking point, that is peak point, that is only non-linear. In the non-linear, very light research is there in all aspects actually, but that is very most dangerous zone actually in your load displacement response of the any structure. So in the non-linear point of view, the research is going on. So performance based design, how it is, very quick view I'll show. I explained you in that actually it has been introduced another one method actually in the performance based design. See what is PVSD, performance based design means an innovative engineering approach to design elements of a building based on agreed upon performance goals and objective for various levels of hazards using accepted engineering tools, methodologies and performance criteria. Why PBSD? Multi-level hazards are considered with explicit definitions of the structural performance, analytical method for rationally obtaining the nonlinear behavior of the structure. Current seismic codes are not suitable for tall structures. Excellent approach for rehabilitation of old structures. Minimum life cycle cost. Of course, this is a basic methodology how it has been adapted the PBSD. Of course, I'm not going into detail here. I'm moving on to the major differences in overall design, the code-based design and design based on performance. Actually, it's a direct design based actually. This is one another method which is adopted in the performance based design, but this is a code-based design. The
Sir, there might be some problems, sir. Sir.
Yeah, is it okay now?
Yes, sir. It is okay now. Please go ahead. Share your screen.
Yeah, I'm sharing screen, and I think I may take 20 more minutes. Girish, is it okay?
Yes, sir. Okay, sir.
Okay. It is larger sections are more reinforcement, hence economical, and it's a lighter sections, lesser reinforcement, and hence economical. So that is a basic difference. And of course, these are the details for one model actually, because I'm not explaining about this because I've implemented for the one for the PhD scholar, for maybe for the one MTech student, but it doesn't matter actually. But what is my main objective in the today's presentation is you must know the different ideas about the soft computing techniques in the structural engineering. So by using so many softwares, like it may be a finite element based software, it may be a typical numerical based software like analysis based software, like that. The plan and elevation can be seen here, and this is response spectrum. Yeah, this you can see here, this response spectrum taken from the code book. IS it's a 1893 code book actually. So that code book has recently like revised in the year of 2016 along with the IS 13920. IS 13920 earlier it was not there. So IS 9330 it has come in maybe 2000 or sometime. After that it has again revised. It's an athletic code book along with the IS 1893 code book. IS 93 code book only main code book. Earlier it was, we don't have ductility code book. Ductility code book came only not even 2000. It came after Bhuj earthquake. In the year of 2001, Bhuj earthquake occurred. In the year of 2002, IS 1893 code book has been revised in the form of, I think, 5th revision. So the response spectrum is this, the damping levels, and this can be seen in the code book. So I no need to explain anything over here because nothing new. It is like an open book. It is available from the code book. But here, the acceleration due to gravity, that SA by G is this one, and whereas this SD graph you can see here for the different damping values, the displaced response spectrum. This is acceleration response spectrum. Okay, and DDPD parameters for design, like what is base shear, like what is horizontal force, like delta top. Delta means the displacement, even equivalent load, horizontal load, and even movement, and even yield displacement. Okay, like that. And design force-based design values. These are actually, and column design using force-based design. Design. So beam again beam design with the DDBD. So column design with the DDBD. There are totally different. Maybe you are not observing because I am just going into very faster. The cross sections of the beam and size of the beams are totally changing from the FBD to DDBD actually, double DBD. So column design for the base shear values are lesser, around some 25 to 50%. So different base shear distributions are there, like comparison of materials used. So frame, like consumption of concrete, 10.23 meter cube, whereas DDBD3, 9.3. What is 3? That means 3 floors, 5 floors, 8 floors, like that. Okay, that is a parameter. So there is a whose saving difference is whose saving is there in the form of concrete saving, even in the form of consumption of steel also. That we wanted to show the difference. If you really use at the same time, you don't need to compromise about the structural integrity if you really use the performance-based design. But sir, how we have to use? I'm very fond of using that, but where are the guidelines? Wait for a while. The guidelines are getting ready. Those are going to come into the drafting form. So for that, our very experts from, especially from committee from IITs, and they are working on it. They will bring you on to the implementation. Hinges, hinges at the columns, and summary of performance points, like whatever the points you have calculated, like base shear, like response spectrum, SA values, and even displacement spectrum, SA values, SD values, like that. And different stages of plastic hinges. This is what actually I was supposed to show in the pusher analysis PPT, but the same thing. In the pusher analysis, after getting the pusher curve, actually you are getting immediate occupancy, life safety, like collapse, then again something. This level you should not go. So these are the levels in the pusher analysis. It will decide your the level of the present status of your system. These are the demand curve versus capacity curve. Actually, the demand curve where it is falling, it is basically is a safe design. Capacity curve and demand curve, it is a safe design, whereas it's an unsafe design. Demand curve, it is going beyond that, because the building is under big problem structurally. Then pushover and demand curves, because in the performance based, and again pusher analysis they have done. They used the performance basic design, but with the help of pusher analysis, they shown the behavior of the building. You can see the lot of benefit and a lot of difference is there for the pusher curve for the 3-story in the FBD form, and whereas in the DDBD and double DBD method. Okay, the demand curve, you see, if you see, of course this is capacity curve. The curves, if you see remaining curves, these are the demand curves. These are most safer actually in the DDBD method actually. And this is for the 5th floor, that it is also similar to that. The effect of the demand curves are more safe zone in the DDBD method. Similar for the 8th story and the damage states. The effect is very, very reduced actually. Conclusion, base shear by DDBD method are much lower. Code-based design products achieves basic objective of life safety. Indian code-based design leads to conservative design. D/C ratio of 1/4 required to protect column from damage, which increase in height DDBD becomes more effective. Now, position analysis of RC building compared to study and seismic zones of India. What we have done in this idea actually, we have taken the same building, same dimensions in the different locations. Say building is located in Hyderabad, same building is located in Vijayawada, same building is located in New Delhi, same building is located in Guwahati. Different seismic zones actually. Hyderabad zone 2, Vijayawada zone 3, New Delhi zone 4, Guwahati zone 5 actually. So by taking the all zone factors differently, how your building is behaving. What is the obviously zone 5 building only will behave differently because the zone factors and everything is different. But we wanted to see the behavior of the same dimensions of the beam, column dimensions, height of the building, length of the beams, everything same. So that should we have shown here. The if you see the basic idea about this idea behind this, conventional elastic design method don't give realistic basis in severe earthquakes. Inelastic time history methods are very powerful but computational and complex and not feasible for most of the practical applications. Pushover method of analysis considers inelastic response characteristics and it can be used to estimate the dynamic demands imposed on the structures during seismic excitation. So like this description of study area, you can see that how we will apply the pushover analysis on your building. Importance of the pushover analysis, as I already explained. Of course, this is and also explained, and methodology and details, plan, and again plan view, again demand curve. Finally, after doing the analysis, you're getting the curves like this. The comparison of performance values you can see. The spectral analysis m by second square, that is acceleration for the zone 2 is very lesser, whereas for zone 5 it is obviously higher. Then displacement, you see how much it is coming for the zone 5, very heavy. Base shear also very heavy, and even effective time period. Time period also most important actually. How much time the earthquake has come and what is the R value. And damping ratio is also totally different from the zone 2 to zone 5. This is a basic comparison, and hinge formation pattern also totally different for the different zones. And observations, whatever I already explained you, and of course conclusions. And now behavior of the soft story. Same again, soft story concept is another very good concept. Generally, you might have observed the so many apartments. In the apartments, for the parking area, as I told you, that is nothing but a stilt area. What they are giving, they are giving like a open column section. They have to construct the walls. If they construct the walls, what they will face the problem? For them, easy moving and flooring, like parking will be very difficult, and lighting also very difficult. They must use always lights on. For that, what they do, they will not construct any walls along the columns actually. They will keep open, but they will only construct boundary wall. That boundary wall different. After setbacks only they will construct, no? So that will create a lot of problem, especially at the stilt floor, because relative displacement from the top floor and bottom floor will be different. Then it will create the soft story effect. That means when earthquake comes, there will be a major chance to fail at the that is stilt floor columns, because for the stilt floor columns are isolated, ideal actually. There is no infield wall connection is there. Infield wall support is not there. That is why relative displacement will be, that is nothing but a drift ratio will be different from the top floor to bottom floor. There only the soft shear problem and idea has come into picture. For that, how to use the again like pushover analysis for knowing about the soft story effect on your buildings. What is a soft story? A soft story is a one in which I explained already, lateral stiffness is less than 70% of that in the story above or less than 80% of average stiffness of 3 stories above it. Introduction. Many buildings that collapsed during the past earthquakes is mainly due to soft story effect. Majority in the Bhuj earthquake also in the year of 2001, Gujarat, soft story effects. Conventional elastic design, IS code method don't give realistic seismic performance of structures in medium and severe earthquakes. Soft story effect, soft story building in nature acts as a, of course, I'm not going into read everything. So this is basic problem you can see from the photographs. This will act like one inverted pendulum. So if there is no infilling walls, the building will go like this. It may not come back actually because it is not elastic one. So it is a rigid connection. So if you want to make it into a little bit flexibility, so you must provide some, some dampers. So dampers you may not provide, but in the place of damper, your building must be designed for the mx double dot plus cx double dot, cx dot plus kx equals to 0. This is a free vibration. What is C? Damping coefficient. Okay, and m is mass, k is stiffness. So x is displacement, x double dot is velocity, x double dot acceleration. This is what equation of motion. No, so from there only D'Alembert principle has revised that equation, and he introduced the equation and he has provided. By using that one only, we are doing all earthquake calculations. That all code book also has come up with from that calculations only. And you can see the soft story effect due to the soft story effect, how buildings are collapsing here. Yeah, necessity and purpose and methodology and some things. And again, in the software, you can see this, how it has been taken to control the soft story effect. The one idea also we have explored here, the equivalent diagonal compressive struts. When you introduce the equivalent struts diagonally, there is a chance of reducing the soft story effect. And pushover curve you are getting here. Then time period to performance points. Then this is what idea, that is soft story effect idea. Okay, thank you about this my presentation of PPT, but I'm going to show one video which is there in the ANSYS software, how to analyze and design and analyze the basic, that means how to do the modeling and finite element analysis on the shear wall, because shear wall is the most critical portion of the structural element, I feel, because it will resist the so many lateral loads in the form of earthquake loads. That is why I have taken that is as a one example, and step-by-step procedure in the ANSYS workbench. Actually, workbench is advanced to the basic ANSYS interface. So in the workbench, it has been done step-by-step procedure. It has been recorded. You can see in the background, I will give the voice, what is happening there. But finally, you can see the total modeling, how it is. I may skip also because I may fast forward it because it is somewhat lengthy. It may take around some 20 minutes, but I will try to reduce into maybe 10 minutes, otherwise less than that. Because the overall idea only you have to understand. It's not that everything we have to show in the presentations. It is not possible because it is not a classroom. So I can take 10 hours time and to explain. So it is very precious time, valid time for everybody. We must utilize very effectively. That's why please bear with me for the 10 more minutes. I'll show that. I'm stop sharing now here. Are you able to see this, Girish Garu?
Yes, sir. Sharing, sir. It is sharing now.
It is getting sharing. It is open?
No. So do one thing, sir. Just start playing it and then share, sir. Open your video, then you can share that.
Okay. Is it open? Is it open?
Yes, sir. Yes, sir.
Running?
Yeah, it's running, sir.
Yeah, you can see from here in the interface of the ANSYS workbench of any version. If you take generally when you do the any structuring point of your work, there are number of options like structural, thermal, because ANSYS software is not limited to only structural applications. Actually, it is for earlier for mechanical people. But after mechanical people, slowly what happened over the year of time, or the period of time, our people also, civil engineering people also, like who are working in structural point of view, like in different, even for FEM, can be used for any kind of thing, like for transportation also can be used, even for water also can be used for the dam design and all. But their major role is structural engineering, engineering role only will be there. So there, when the requirement has been come into picture and it has demanded, they included the structural, but earlier it was not there actually. So it was meant for the mechanical people. Later on, over the period of time, maybe 15 years back and 20 years back, so this has been implemented towards civil engineering people also. Maybe early, before that also it has come. But the basic thing is, when you open the interface of the your workbench of your ANSYS, the menu will show like this. That number of disciplines: structural, thermal, even ANSYS fluid, even floatron, CFD, like magnetic nodal, magnetic edge, high frequency electric, like that. So that means this many people of disciplinary people can be used to these options like that. That is the meaning of that. So once once you click on the preference only, it will show like this. You will move on that. You have to click the structural, then say OK, then go to the pre-processor. First, we have to do the pre-processing. After doing the post-processing, in the ANSYS, you have to do the pre-processing. In the pre-processing, select the element type. In the element type, again, edit, add and edit, delete button. But it is very fast actually. You can try to observe. I will give only background voice. Then add it and take the beam. In that, take the link option, go to the apply and go to the solid. And in the solid, again, concrete 65. In the concrete 65, once you select, link 180 also you have to select. Link 180 you have to select for the steel. Concrete 65 you have to select for the concrete. These are the models like interpreted in the ANSYS software. Of course, few of the people knows about the ANSYS already, so you are not new into this, but I have taken as a one example to explain you people under the topic of soft computing techniques. I'll go back. After adding the solid 65, 20 node 186 nodal thing also you have to select. That is for solid 186. Next, real constraints. Add link steel cross sectional area 50.26 means 12 mm dia. 5d square by 4. Again set to area. Another steel 113.1. 20 meter square, because that is main steel, and maybe 50.2 maybe for links actually, because 5d square by 4 for the main steel as well as links. That is why that area has been added. After that, metal models, then structural, linear, elastic, isotropic, then Poisson's ratio, Young's modulus and Poisson's ratio. Young's modulus giving for the concrete, and that is 5000 root FCK, I have to calculate, and 0.17 it has taken for the steel, concrete, the all values. Calculated values you must give here. Density of the concrete. Yes, okay. That is for steel. 0.3. Okay. Yeah, this is actually most important. When you go to the rate dependent one, what is own misses criteria means? These are basically failure criteria. Own misses criteria we generally select for the steel, whereas Tresca criteria we generally select for the concrete actually. Yeah, density also given for the steel. Isotropic. Again another steel. Poisson's ratio. Yield stress. Yield stress. Again density. For both steels, density and Poisson's ratio, everything has been given. Because three things we have created here. And here, what is the option? When you see after applying this one, you have to come on the interface of the diagram and you have to do the replot. Replot means whatever you do the process and everything, it will be like refresh actually. So once you are not doing refresh, the overlapping and the little bit other problems, technical problems you may face. The model when you are running, it may not run properly. So that is why you have to do the replot. Okay, replot means it will give the refresh. Then section properties, create key points in active CS. Now creating the key points. Apply 0, 0 already completed. Now another key points. Yeah, 150 along the X direction. Then now we are giving along X and Z direction. Yeah, created. At 2 nodal points. Yeah, 3 nodal points also done. Copy key points. Yeah. Okay. After selecting the key point, the distances and you can add it. Okay. Through key points. So what it is being created now? It is created actually boundary elements for the shear wall. So this is in between wall is the shear wall. These are the boundary elements. Boundary elements are most important for the shear wall because it will resist the lot of shear due to that boundary walls actually. It will actually shear walls are most predominantly fails in shear, but to make into that you have to convert into flexure actually. So that is why they are calling it as a shear wall. Okay. So now you can create here from there like height of the shear wall. Once you create that by giving the thicknesses, like offsets and all, you can finally create like this. The shear wall will be created like this. Okay, model maybe maybe that much not important. That's why I'm skipping this. But it's a repeated procedure. What are these actually different colors? It is internal reinforcement basically, because vertical reinforcement, horizontal reinforcement is also most important in the shear wall actually. See, once that is created, horizontal and both vertical reinforcement has been created, then the model is ready now with full steel in both boundary element as well as main shear wall. And now continuity. See, likewise, it can be created. And whatever created, you have to just same style only, like what you have to define first, you have to create the model, then after that you have to assign the things. Yes. Yeah, this is another important portion in this ANSYS software. Discretization is also most important. So 8 noded elements you have to create. Each and every 8 noded element, we see sometimes you may require serendipity. Serendipity means without any support, if you want to keep any nodal point, that is nothing but a serendipity. And 8 noded element at each and every nodal point, if you get the displacement altogether, if you make it into like average of the all displacement, very accurate displacement you will get. That is why finite element analysis is most popular. But finite element analysis cannot be done for whole structure actually, because the whole structure, if you want to do, the whole work will be very higher, and the analysis and modeling is so difficult. That is why particularly I would take the one particular element like beam or column or in any shear wall. Then you have to do the modeling. It will give very good accurate results, and we can do the lot of analysis on this after doing this modeling, finite element analysis. For doing finite element analysis, there are plenty of softwares, but most popular one is ANSYS and Abacus, and even NASA, MASA also most popular. Not here actually. TNO Diana, this is also very popular. But these are not user friendly. But when you talk about the ANSYS, this is not that much user friendly actually. So there are some drawbacks with the different softwares. Some some missing parameters and some things also there. But accuracy point of view, the ANSYS is very good, and Abacus is also very good. Depends on your work levels. Like flight is there now for mechanical point of view. Take flight, aeronautical people, they design everything in the Abacus. Even some very advanced finite element softwares actually. So likewise, after doing analysis, modeling, you can do the analysis setup like this. Now fixity also given at the bottom. So this is the way of doing the analysis, modeling and analysis of the on shear wall in the ANSYS software. Maybe inside there are so many points, but I have not explained you thoroughly in detail. But I just wanted to show you the overall idea how to do the basic analysis and finite element analysis, how to perform on the one particular model, to very higher model, that is shear wall model. That is my main objective for this presentation. Okay. Yeah. So this is all about your explanation. Yeah. Last video it is getting running. It is over, I think. Yeah, it is over. So with this, I just wanted to close my presentation. ANSYS I have shown, even I have shown SAP 2000 software, I have shown Etabs software, even I have shown STAD Pro at my starting presentation. So I feel that finally I have fulfilled the objective of the today's short-term training program on soft computing techniques and civil engineering. But particularly I have selected the soft computing techniques on structural engineering point of view. Different ideas also we have shown, like pushover analysis on performance-based design, like comparative study on different seismic zones, even soft story effect, like that. So finally shown the like ANSYS modeling also. So with this, I would like to wind up my presentation. Thank you one and all for patience listening. Thank you, Girish Garu, over to you.
Yeah, sir. Thank you so much, sir. Thank you for your nice presentation and lengthy presentation. Good. We are able to know. Actually, I know only ANSYS, Abacus, STAD Pro, SAP. You said so many softwares. I really don't know that. First time I'm hearing that. Very fortunate to hear that we have a lot of softwares to do analysis and structures. Yeah, this is now session is left to the discussion part. Participants who are having questions, you can raise questions through chat box, or you can even unmute yourself.
Chat box. Chat box. I am taking questions.
Yeah. Okay, sir.
Very well conducted. Okay, informative session was informative, clear and simple presentation. Thank you, sir. Okay.
So we are requesting participants to post your questions in the chat box so that the speaker can address your questions very quickly.
Okay. No one is asking questions. They are only asking, please send the PPT or something like that.
No. Last one. We go to the last. Somebody is asking question.
Cantilever slabs. Yeah. See, cantilever slabs can be created like you can create by with the nodal point supports only, but the when you create the nodal points at the bottom also, the connection you must give. That is only you will face the problem actually. So what you do, you create the beam, but you make it as a one dummy beam actually. You no need to give any dimensions like that. Then automatically it will be shown as a dummy beam. Otherwise, one more idea also I can tell you. Instead of creating the cantilever beam, what you do, calculate the whatever the load is coming on the cantilever beam. So that total load or the total bending moment you can transfer to your fixed beam actually. So that is also one idea you can do it. But typically, if you want to draw the cantilever, that is another one idea procedure. But another procedure I told you, first you calculate the all load, whatever in the form of uniformly distributed load coming on your practical point of view cantilever one, that in the software transfer onto the one fixed beam. So because cantilever beam is actually one side is free, another side is fixed actually. So in the condensed beam only, cantilever portion may be there. That is nothing but overhang beam. So in the overhang beam, say condensed beam, already 3 spans completed. Last portion is cantilever portion. Altogether, we will call it as a overhang beam. But particularly, if you talk about the last portion, it is typically looking like a cantilever beam. So like that, you can do. CAD software. Yeah, I hope I clear your answer. Next, can you please mention the better concrete models in ANSYS or in Abacus? Concrete models means? Yeah, concrete models means that is one, solid 65, that is one link. Solid 65 is the best thing actually to select the concrete models in ANSYS software. Yeah, next one is, can we directly export the AutoCAD drawing to SAP software? Yes, we can. SAP actually, SAP software developed by country, because SAP software conducted by Sweden country, because it is not much popular, because it is using most of the metropolitan cities like Hyderabad and Bangalore, and SAP software is also most accurate and very user-friendly software. You can export the drawing, and even after completion of the analysis and design, you can directly generate the AutoCAD files of your whole design. Design and drafting, like foundation details, column details, slab details, directly you can send for the even execution also. That much benefit is there from the SAP software. Soft computing techniques using MATLAB and Python scope is there. Why? Because by using MATLAB, we can do the mixed design also. I have that coding. Mixed design for the any mixed design, even M100 mixed design also you can do using MATLAB coding, mixed design. Python nowadays they are using for everything. Python I have seen recently for water resource engineering also, like dam design, like even hydrographs. Even I have seen for the geotechnical applications, Python I have seen. Because Python is almost look like a MATLAB coding only, but it is very less steps actually. Number of steps are very less. I'll give the one comparison here. Earlier it was, we have C language. Later on it has come CPP. Why C language, high level language it has been clicked actually? I'll tell you one great example. There is one company having around some 1,000 employees are there. 1,000 employees in a day, if you see, minimum 10 to 20 people on any grounds, they will take the leaves. At final, after 1 month, you have to give the salaries, being as a one employer. So how to make the salary slips for them? So you can't make manually. It is very difficult to make. So if you use the C language software, and if you draw the code, if you write the coding like printf, scanf, or like that, and else if loops and all, easily by deducting the all leaves and by deducting the medical leaves, any other benefits, like if you want to get the OT, like overtime benefits, any money extra, that everything can be interpreted in the software. That will give fraction of seconds if you do compile by clicking the F9. Whereas manually, it is very difficult. But the great example I'll tell you, if you want to do the addition, 1 plus 2, how much? Girish Garu?
3, sir.
3. So this is, we can directly tell.
Yeah.
What is 1,20,000 plus 1,28,000?
2 lakh to 40,000 around.
Sometime you're taking. That
Yes,
is also
yes.
rounded figure I told you, that is why you took less time and you're telling. If it is very fraction value, it is very difficult to tell by manual. So software will give in the same time 1 plus 3 how much value 4, and if you put the higher value also, software will give in the same time. That is a great advantage with this MATLABs and C languages and all. MATLAB again, it has the advance to the C language, like number of steps, number of coding steps are it is reducing. Again, I will tell you, Python is again advanced to the MATLAB. Nowadays, they are using for the different applications, different project works, using the MATLAB and of course Python. By using MATLAB, I have seen especially in IIT Madras, they are doing so many projects. Like one Indian government has given project to the one professor. What is the project means? Do the shear force and bending moment diagrams for the Indian plates, whole Indian plates, by assuming it as a Himalayas as a fixed support, whole from Himalayas to Kanyakumari as a one cantilever beam, and one normal horizontal thrust also applied from the Indian Ocean. Indian Ocean nunchi tides vasta untayi kada. So a tides hitting they again simulated to one normal thrust. So that all uniform distributed load they assumed as all streams, ante vagulu, vankalu, and again the all hills, even kondalu, ivanni untayi kada, that they everything simulated as a one uniform distributed load. Then they used the direct delta function and step function. They are not used any cut section or using for calculating shear force and bending moment diagrams. They used some mathematical modelings, that is step function and direct delta function. They finally found the shear force and bending moment. From there, they found the geometrical properties of the all areas, and they decided that future prediction of the earthquakes. Further, they used MATLAB. See lakhs of lines of the MATLAB coding. For that, they used the supercomputer. Supercomputer means you know the RAM GB itself, it will be like 100 GB, 64 GB RAM. Very fast supercomputer. No man entry into that room actually. It will be everything operated in the remote desktop. Like that, they used it. That kind of things I have seen using with the MATLAB. Now Python is also getting very popular, very advanced. Thank you for the very informative session. Can you please tell which software is better for the bridge analysis? TNO Diana, this one, another one is, what is that? Midas Bridge. Midas Bridge. I am typing here, Midas. Midas is there for so many things. Midas is there for the buildings also. Midas is there for the bridges also. TNO Diana is which is connected to the finite analysis, as well as basically it will look like a interface of the Etabs. Etab interface la kanpichedi Midas, and Midas bridge is very, very good for the bridge analysis. How to model basement floor with cantilever wall. Also, please tell about the RCDC software. I don't know the full form of the RCDC software. Please respond on this, Anjan Kumar Garu. Venkatrao Badugu. Thank you for your excellent session, and also thank to excellent organizing teams. Okay, thank you, sir. Yeah, that's all, and I think that's all. See, Midas is actually very good one, as according to my knowledge, actually.
They were asking other software, sir. Is there any other softwares? You told so many Diana and also some.
Yes,
so
struts on the strap on the strap. Actually, again, I'm telling you the story. Strap, why it is not popular in India, but it is running in Hyderabad. Very good consultants, very good, even very good design companies they are using. Why it is not popularized means, I'll tell you the one interesting story here. 2 minutes only. Any software it has to popularize it entire the world means, first of all, that software should be used effectively in the UAE countries and United Arab Emirates countries. That means Abu Dhabi, Dubai, Oman, ikkada vadalavi. So that software, if any software is popularized in that countries means, that software will be popularized in the whole world actually. Why strap particularly not popularized means, very good software strap. You can see on that. Why it is not popularized means, it is developed by Israel actually. It is a full name actually, Ether strap. Ether. So there was some disputes between country to country of the that Israel and this UAE countries is this Dubai and Abu Dhabi countries. That is why they banned that software. That is why that software is not popular, but that software is very popular in like Sweden, a few places in America, UK, Australia, very few places only, but not that much popular like StatPro. Not that much popular like Etabs. Etabs, why it is very popular means it is very useful for the tall building structures. You know, Burj Khalifa constructed and hotel analysis done by using the Etabs software. Like tall building structures, P delta analysis, like full wind analysis can be done using the Etabs software. That is why it is very much popular. Yeah. Anything else?
He told that reinforced concrete detail software, RCDC, something he was telling me.
What's
That
it?
Ranjan-
StatPro, Etabs, Etabs. Okay, I will write another software also. NASA. You can type it in the Google. TN Diana. Midas Bridge. Whole Midas package also very good actually. Whole Midas package. Yeah.
So someone is asking about some book reference for a spectrum analysis, response spectrum analysis, and pushover analysis for better understanding. They're asking to suggest some reference books.
For pushover analysis, better I suggest you to go through the journal papers only, like research papers, research publications only. You don't need to particularly approach or read the textbooks on pushover analysis. Better on pushover analysis, there are plenty of research articles are there. Just to go and type it in the Google, pushover analysis. Pushover analysis on different structural elements, I'm telling you. But you will understand what is meant by pushover analysis, how to do the pushover analysis, how to use the pushover analysis in the different softwares also. You can do pushover analysis can be done in the Etabs software also, my dear participants. I maybe missed it to mention that you can do it in the Etabs software also, pushover analysis. Okay, better you can read the.
So one last question you can see.
There is this project on dynamic architecture where the floors of building will be rotating. Can you say anything about it? If one wants to do that as a project on PG level. I didn't understand this question. Can you read it, Girish Garu?
Sir, he is asking about doing. Have some project on dynamic architecture.
Maybe floating columns, I'm thinking. So floating columns means like the column which is not coming from the bottom. That means from foundation level, it is not coming. In between, you wanted to introduce the floating column. So that can be done, but very pakka design and planning and very good execution. The only you can introduce the floating columns. I'm thinking that. Other than that, otherwise you can give access to him, that Prasanna Lakshmi. Access to her. She can ask.
Prasanna Lakshmi. Yeah. You can talk now. You can unmute and talk.
Because
sir,
I didn't
thank you, sir. Hello,
understand.
sir. Good afternoon, sir.
Good afternoon.
In Dubai, actually, they are planning for a tower which will be able to rotate. Each floor of the building will be able to rotate, sir. Dynamic architecture.
What is
as rotating tower. Sir?
Sorry to interrupt you. What is
Yes,
the
sir.
mechanism? What is the mechanism they are arranging for rotating the building?
No, sir, I don't exactly know about that. I got to know about it a few years back, and there are few videos also in YouTube. And after seeing that, there will be interest in us, no, sir. Curiosity, what is the mechanism used and how are they able to rotate that each floor of the building? And there is also this building in Brazil, sir, Smith Wallard. In that also the floors will be rotating, but I don't exactly know the mechanism there, sir. If you can give any information about
may I know rotating in which direction?
Clockwise or anti-clockwise, sir. Floors will be rotating horizontally, no, sir.
Okay.
Like that.
Yeah, actually, first of all, there is a sliding mechanism will be there, but to control that sliding mechanism, I am thinking that there will be a external dampers are there. In the dampers point of view, if you list out, there are elastometric dampers,
Yes, sir.
Coulomb dampers are there. These dampers basic duty is to reduce the C value actually. That means vibration in the building. When it is rotating with heavy load,
Yes, sir.
there will be a chance of lot of
Lateral
rotation,
forces.
lateral forces and rotation and vibrations. This
Yes, sir.
vibration is the main criteria to reduce that. For that, they might have provided the dampers. So these dampers duties to reduce this vibration, the C value. If you see in the equation of motion also, mx double dot and cx dot and say plus kx equals to 0 is there.
Yes, sir.
We will not provide any damper separately. But there is a one building constructed 25 years back. Now zone comes under the zone 5. Now you wanted to reduce the vibration, whatever coming in that building. That building is very valuable building, and you can't dismantle that building and you can't reconstruct that building. You want to building remain same so that external dampers they can provide for this building. Even rotating point of view, if you talk about, I have seen one video, maybe in the Facebook actually, there is a one parking arrangement in the Dubai or somewhere I have seen. There is a parking arrangement, one vehicle, one car will be there, vertical arrangement of the parking. One car will go there and that car will be rotated to the another level and another car will come. And again, that another car will be rotated like that. All cars will be rotated like this. 20 cars you may replace at the only one car place area. To save the basically parking area, that arrangement they have done. That is also rotating arrangement actually. So maybe that kind of arrangement they will provide. But here the major problem, major consideration is dampers.
Yes, sir. Thank you, sir.
Please try to work on this by downloading some papers from especially ASC, like American Society of Civil Engineering, or maybe metal and structures, like elsewhere papers. You try to search some papers on this. Obviously, you will get some idea and you'll get some articles. If you get one article is enough. For that article, there are some references. In that references, if you see, there will be a one or two papers suitable to your way of work, your
Yes,
study
sir.
of
Yes,
like that
thank you,
way.
sir.
All right, sir. Yeah, we have you have spent sir, are you
Voice
able
is
to hear me?
no,
Sir, hello, are you able to hear me?
voice is breaking, Andy.
Sir, is this okay now? Hello?
Now it is okay.
Yeah, sir. Thank you so much, sir, for bearing us so much, for giving us so much of time. We actually have good amount of time with you. Very happy to have this discussion part with the participants, and also I hope and believe that participants are utilized this session fruitfully. And we are very happy to thank from the Department of Civil Engineering, SVCW, for accepting our